Hi, welcome to Gateways to Mathematics. I'm Herb Gross, Professor of Mathematics, and I will be, so to speak, your tour guide for this excursion into the world of mathematics. I'm assuming that by virtue of your joining me in this discussion, you are very seriously considering taking this trip into the world of mathematics, and it will be my job, in fact my pleasant task, to try to make this trip as enjoyable, as meaningful, as fulfilling, and as horizon expanding as possible. At the conclusion of this course, you should have a better awareness of mathematics, you should have higher self-esteem, you should, in general, just feel very good about where you're going and what the horizons will be. Now, one of the reasons I open this way is that it has been my experience in over 30 years of being a mathematics professor to find that people, by and large, are afraid of mathematics. And in the last few years, this fear has been enhanced by the coining of the term math anxiety. See, people now say I have math anxiety. The point is, there are people who have math anxiety, but most people who have trouble with mathematics are not suffering from math anxiety. In much the same way that there is such a thing as dyslexia, but not every poor reader is dyslexic. There is such a thing as burnout, but not every person who dislikes his job has burnout. The point is, there are reasons that people have trouble with and or dislike mathematics, but ironically, it very often has nothing at all to do with mathematics. On investigating why people have trouble with mathematics, we often find that it's a psychological problem, there's a fear problem, there's a language problem, and all sorts of things. And what I want to do in today's lesson is two things. I first of all want to explore the reasons why people have difficulty with mathematics, and I also want to make clear to you how I intend to organize this particular course. I'm reminded of the story, it's a cartoon actually, showing Noah's Ark, a very, very damp, rainy day. It's been raining for a long time. There's miles and miles of animals waiting to get onto the ark. Oh, it's awful, they're drenched. At the very, very end of the line are two zebras. And one zebra is saying to the other zebra, "Darn Noah and his stupid alphabetical order." Now that cartoon may or may not be funny. I notice half of the crew is laughing, half isn't. That's okay. I think it's a funny story. First of all, that's why I told it. More importantly, there's a message to that story. Suppose, for the sake of argument, you wanted to translate that cartoon into another language. Do you realize that you might have to change the picture? What made that story funny wasn't the animal zebra, it was the word that named the animal. You see, if in another language the animal zebra has a name that begins with a letter near the beginning of the alphabet, that isn't even a funny story. And you see, here we come to the crux of the situation. Any language made up by human beings is called an artificial language or an arbitrary language. And what happens with an artificial language is you talk about concepts, but all you see are words. And the big danger is that you may be confusing the word with the concept. And rather than me droning on and on this way, why don't we just go over to the board and really get our feet wet and immerse ourselves in our first discussion. You see, in an artificial language, we discuss concept, but what we see are words. Now let me give you a very trivial, contrived example. Suppose in the middle of the room is a black cat, and I'm going to ask you questions, you're going to give me truthful answers. So I say to you, true or false, the cat is black. Most likely, you say true. Now, referring to the same cat, I say to you, true or false, el gato es negro. Now, el gato es negro is Spanish for the cat is black. Suppose you don't know Spanish. You can't say true. You can't say false. You're going to give me an honest answer. If you don't know Spanish, about the best thing you can do is to say, I don't know. Well, why else might you have said you didn't know? Is it possible that you understood Spanish and still would say, I don't know? Well, suppose you were colorblind. Suppose you were colorblind. I say to you, true or false, the cat is black. You don't know, you're colorblind. So you say, I don't know. But here's the point. If when I say to you, true or false, the cat is black, and you say true, then I say to you, true or false, el gato es negro, and you say, I don't know. You don't have a vision problem, you have a language problem. because if you were truly colorblind, you wouldn't have been to be saying it was true when I stated this thing in English. And this is the point I want to make. For example, many concepts are difficult even when they're explained to you in your natural tongue. The theory of relativity, for example. Lots of things are hard. But the problem is, if somebody is explaining something to you in a language that you are not comfortable with, in fact, let's make it even easier. It's a language you don't know. Is it possible that when you become confused, it wasn't because the concept was hard, it was because you didn't understand the language? In other words, the problem with having a language problem is that when you don't comprehend, we don't know whether it was a language problem or whether it was a concept that was so difficult that even if you knew the language, you still would have had trouble. You see, we've got to distinguish between the concept and the words that are used to denote that concept. Let me just give you a series of, well, not so funny, but hopefully enlightening anecdote type of riddles. The first one says, what word becomes shorter when we add letters to it? What word becomes shorter when we add letters to it? Well, you know, if you're thinking conceptually, adding letters onto anything makes the word longer. But be careful. You see, pretend I'm talking about the word. See, when you put quotation marks around something, it means the word. You see, what I'm saying is, start with the word short. Add on the letters ER, and the word short becomes shorter when you add on the letters ER. The word shorter is longer than the word short. Do you see the difference between the concept and the name of the concept, the word and the concept? Let me give you another example. Rearrange the letters in new door to form one word. See, make one word out of new door. Now, if you've seen this riddle before, you know the answer. If you haven't seen the riddle before, it's just exasperating because if you don't see the trick, you can work on this for a long time and not get the right answer. And when you do see the trick, then you get aggravated that somebody kept you in suspense that long. So let me just go on and show you what the trick is. You see, the way you arrange the letters in new door to form one word is exactly this. Look, the N, the E, the W, the D, an O, and an R. In other words, the letters in new door can be arranged to spell O-N-E-W-O-R-D, which is what? One word. The phrase one word is two words. Do you start to see the idea of the word versus the concept? Here's a mathematical one. True or false, 4 plus 5 is 10. 4 plus 5 is 10. Certainly false as a mathematical statement. Now watch what happens. Let's start with 4 tally marks, which I've made in blue here. And now I'm going to add on 5 more tally marks, which will be in red. See? 1, 2, 3, 4, 5. 4 and 5 are 10. Does that mean that 4 tally marks and 5 tally marks are conceptually 10 tally marks? No. It means that 9 tally marks can be arranged to form the word 10. And the point I'm driving at is that symbols used to name numbers are called numerals. See, just like in any other artificial language where you see words but you're talking about concepts, in mathematics we talk about numbers but we see numerals. Okay? We see names of numbers, we don't see the numbers themselves. Let me give you an example of that. How about this riddle? Half of 8 is 3. Half of 8 is 3. Well, certainly as a number statement that's false. Half of 8 is 4. But suppose I take an 8 and just split it down the middle. Half of the numeral 8 is the numeral 3. So this is what? True as a numeral statement, false as a number statement. In fact, one could have argued, why didn't we take this half of the 8? In which case we would have counted 1, 2, 3, 4 this way. And I think there's a nice moral here. When I show this to some of my students, they say, but it's unnatural. It's unnatural to write the 3 this way. It's illogical. And what they really mean is that it's been acquired knowledge for so long to use this symbol that this one looks strange only by comparison. You see, if when you were first taught to count, you were taught to count 1, 2, 3 this way, this would have been a very natural symbol. And later on, we're going to show that this type of reasoning actually existed in mathematics. The Romans used an X to stand for 10. What symbol did they use for 5? Do you know? They used V, because V was half of 10, half of X. Also, so they could have used what? This half, or this half, but they chose this half because that was a letter of their alphabet. Do you see the idea here? This is just what I want you to see. Let's get into some more serious stuff. Let me show you how the cat is black and el gato es negro comes home to roost in a mathematical problem. Let me show you 2 problems, and let me see if you can do both of them. Or let me ask it a different way. I'm going to show you 2 problems now, and I want you to decide which of these 2 you would rather have to do if your life depended on getting one right. The first one says, how much is a quarter, a dime, and a nickel? And the second one says, how much is 1/4 plus 1/10 plus 1/20? Now, most people, especially if you're American and know the American system of money, you look at this problem and you write down the answer almost before I finish writing down the problem. You say it's 40 cents. And basically, I don't know even if you bother adding here, maybe you already recognize this, but basically you say what? A quarter is 25 cents, a dime is 10 cents, a nickel is 5 cents, and you say 25 and 10 is 35 and 5 is 40, and you write that the answer is 40 cents. Now when I say to you how much is 1/4 plus 1/10 plus 1/20, you say, I'm not good at fractions. Well, the part that's interesting is, and we're going to keep harping on this, is that numbers are usually used as adjectives modifying nouns. Like when you say 1/4, you usually mean 1/4 of something. Is it 1/4 of a gallon, 1/4 of a dollar, 1/4 of a mile? See, let's take a look at this particular problem and translate it into a real-life situation. Let's assume that 1/4, 1/10, and 1/20 are adjectives modifying a dollar. See, what is 1/4 of a dollar? It means what do you need 4 of to make a dollar? If you divided a dollar into 4 equal parts, how much would each part be? Isn't that a quarter? That's where the word quarter comes from, 25 cents. See, a quarter of a dollar is 25 cents because 25 cents 4 times gives you a dollar. A tenth of a dollar, since it takes 10 dimes to make a dollar, each dime is 1/10 of a dollar, so a tenth of a dollar is 10 cents. And a 20th of a dollar, see, it takes how many nickels to make a dollar? 20. So each nickel is 1/20th of that dollar. So in other words, 1/4 of a dollar, 1/10 of a dollar, and 1/20th of a dollar are 25 cents, 10 cents, and 5 cents. And so what we find out is what? That using the fractions to modify a dollar, part B was exactly the same problem as part A. In other words, if you don't know how much 1/4 plus 1/10 plus 1/20 is, but you know how much a quarter, a dime, and a nickel is, you don't have a genuine math problem, you have a math language problem. And that's the kind of thing I want to concentrate on throughout this course. And by the way, you know, when you talk about fractions, you talk about numerators and denominators. And what I wanted to point out to you in terms of adjectives and nouns, numerator suggests the word enumerate, which is to count, you know, how many, an adjective. Denominator suggests the word denomination, which is size, see, a noun. And you notice what you did over here? People say, I don't know how to add fractions. I don't know anything about common denominations. But what did you do with the quarter, the dime, and the nickel? Didn't you translate them into a common denomination called cents? Then you added up all the enumerations, see, all the adjectives, 25, 10, and 5 to get 40. Then you kept the common denomination that was called cents. You, in effect, know how to do fractions, but you sometimes have difficulty because you don't comprehend the language of fractions. You see the idea here? Let me also show you how many of you are victims of what I call psychological warfare. Let me give you 2 more problems. I'll give them one part at a time. Part A says, at $2.54 per pound, how much will 10 pounds of ground beef cost? Anybody have trouble with that problem? I think most of you put the answer down right away. I think basically what you're saying is what? Since you're buying 10 pounds, and since each pound costs $2.54, you're paying $2.54 10 times. So we just do what? Move the decimal point 1 place to the right. And by the way, if those little statements bother you, we'll be doing these in detail later in the course. learning how to move the decimal point. We do in Module 7 and 8 of this course, but don't worry about that right now. What I want you to see is that most people are not intimidated by this problem. Now let me give you the companion to this problem. I say if there are 2.54 centimeters per inch, how many centimeters are there in 10 inches? And what is the psychological block that comes up now? People say, I never had the metric system. I was never taught the metric system. But in Part A, nobody said to me, hey, I was never taught the ground beef system. When I said the ground beef was $2.54 a pound, nobody said to me, how do you know that? Where did you learn the ground beef system? You see, what happened over here is that you are confusing the fact that a word is alien to you with the fact that a concept is alien. Parts A and B are exactly the same problem, only in a different language. Look, if each inch is 2.54 centimeters, in 10 inches, isn't it true that I'm going to have 2.54 centimeters 10 times? Isn't it still going to be 25.4 centimeters? It's exactly the same problem. You see, what I'm trying to tell you is that if you could do Part A, but you can't do Part B, you don't have a math problem, you have a psychological problem. And where would the psychological problem come from? Let me explain something to you. In mathematics, we talk about rates. And a rate occurs whenever you have two nouns separated by the word per, like miles per hour, dollars per pound, okay? Oranges per lawyer. See, that's called a rate. Now, what happens is sometimes the nouns that are used in the rate are non-threatening because we're familiar with them. When I say dollars per pound, you're used to dealing with dollars and you're used to dealing with pounds. So dollars per pound isn't frightening. But when I say centimeters per inch, the fact that the word centimeter, it has a metric name to it, makes you a little bit frightened. And by the way, it doesn't have to be metric. Anything that we tend to be unfamiliar with, we actually tend to fear. One of the ways of learning to broaden your knowledge is to learn to understand things, because once you understand them, you're much less afraid of them. Let me give you some examples in our own English system, but they're lengths that aren't often used. How about fathoms per furlong? A fathom is how we measure certain depths in the ocean, and a furlong is a typical measure that's used in horse races. But do you notice the psychological effect? Dollars per pound, centimeters per inch, fathoms per furlong are all rates. But somehow you confuse the familiarity with the terms with the degree of difficulty of the concept. This is easy because the language doesn't frighten you, okay? Now, a third thing that happens is we're victims of fear. I'm sure this has happened to all of us. There are times when you become so uptight, what's the phrase we use? My heart was beating a mile a minute, and you just don't think clearly. And when does that tend to happen? When you're the most nervous, when you feel the least in control. Let me show you another math problem that many people get wrong, even though they know better. In fact, I hope when I do some of these problems, it'll be very hopeful if you look at me and say, why does he think we're going to get those wrong? Those are silly problems. But let me give you an example. This is one I use on many people, and this happens. It says, John can paint a room in 4 hours. Bill can paint the same room in 8 hours. How long will it take if they work together? You would be amazed at the number of people who simply say, we'll average it out. 4 hours and 8 hours, we'll split the difference, 6 hours. Do you realize that the answer 6 hours is absurd? And by the way, I put the word absurd in quotation marks. As far as this course is concerned, nothing, excluding me, can possibly be absurd. If you're here to learn, there's no such thing as a dumb question. The dumbest question is the one that should have been asked but wasn't asked. Or as my father used to say, there are no dumb questions, just dumb answers. There is nothing wrong with trying to learn. But the point I wanted to bring out is that most people, once you tell them this answer is absurd, they see it themselves. They recognize that if John by himself could paint the room in 4 hours, obviously with help. With no help, he's going to do it in 4 hours. With help, every little bit counts. It can't be more than 4 hours. 6 hours is an absurd answer in that case. Why do people say that? Because they're so intimidated by the subject. Let me put it a different way. How can something be absurd if you don't know what non-absurd means? If to you the whole subject is absurd, how do you single out what's truly absurd? You see, and that's the kind of thing we're going to be concerned about in this course. Why are you afraid? The language problems, past experiences. I want to use a few cliches for you. One of the cliches is, today is the first day in the rest of your life. I don't care what problems you've had with math in the past. Well, of course I care, but I have no control over that. As far as I'm concerned, this is day one. No matter what problems you've had with the subject today, up until today, that wasn't my fault. From today on, it is. But right now, that's past history. We're starting from day one. We're blameless in this particular thing. And also, you may say, well, he's starting at such an elementary level. How am I ever going to get to anything significant? Let me tell you, and I don't like to boast about myself because there isn't that much to boast about, I have done a series of this type, a video series, for the Massachusetts Institute of Technology, which is a calculus course. And in that calculus course, 90% of what I teach stems from a solid foundation of arithmetic. Arithmetic is one of the most important courses there is. Many people can do arithmetic, but they don't understand it. And because they don't understand it, they can't build upon it. I had a student who once came to see me. I was her advisor, and she said, Professor Gross, I'm going to drop out of the nursing program. And I said, why? And she said, because I'm 49 years old. She says, do you realize that 2 years from now, when this nursing program is over, I'm going to be 51 years old? I says, tell me, dear, how old are you going to be 2 years from now if you don't finish the nursing program? You see, age is going to take its toll regardless. Don't worry about where you are. Worry about today being the first day in the rest of your life, and go with me as we go through the subject material. I will get you to a level of mathematics that will make you very, very comfortable, and at the very least, you'll be able to coexist with the subject. But it's going to take what? It's going to take an effort on your part. It's going to take an effort on my part. The lectures are going to have to be good. The body chemistry is going to have to be there. But more importantly, we're going to need a delivery system. Somehow, there's more to learning than just talking. And I have to discuss, that's the next part of the course I have to discuss with you. See, I've shown you what approach I'm going to use. Now I've got to tell you how I'm going to deliver all of this. And first of all, there are going to be several major themes that will crop up over and over and over again in this course. And here's what the themes are. We've already talked about one of them. It's going to be the language versus the concept. When I teach you something, I'm going to make sure you understand the concept first. Then we'll worry about whether the language is foreign to you. I'm going to make sure you understand that the cat is black. Then I'll worry about whether you understand what el gato es negro means. Secondly, we are going to distinguish between logic and mystique. When we have a formula to learn, I am going to show you in down-to-earth ways why that formula works. You will never have to take my word for it. It will never be decreed. It'll never be a hand-waving sort of thing. You'll never have to say, I will never say to you, we do it this way because I said so. It'll always be an attempt on my part to show you why something is true. Because I believe that most people, when they understand why something has to be, they're able to live with it. The difficulty is living with something you don't like when you don't know why you have to do it that way. And the third thing, which I think is very important, is we will deal with the concept of necessary versus nice. There are some things that are nice not to have to do, but it's necessary that we do them. You see, utopia in life is when the nice thing happens to be necessary, because then we have an excuse for doing what we like to do. But the hardship in life comes when there are necessary things to do, but they're not so nice. And we sometimes squander our life because of that. It sounds like a soap opera, but basically we're going to live that philosophy. It's a dirty job, but somebody has to do it. But it's going to be more than that. It's a dirty job that has to be done, but that by doing it, we're all going to emerge more knowledgeable than we were before. And we'll get into that in more detail later also. Okay? And I just also wanted to give you a quotation from one of my teachers. He said to me, when you've forgotten everything else that you've been taught, what's left is the only thing you can call education. I can fill your minds with facts, with numbers, with computational details, but if 6 months later you've forgotten them, it's the same as if you never learned them. In a certain manner of speaking, we have college graduates who maybe have 10 minutes of education based on what they've retained. And that's not meant as a slur. It's meant to comment on a system where people are forced to pass certain examinations, but once those examinations are passed, no reinforcement is ever given. And I think many of you know for yourself certain courses that you've done well in that you can't even recall the basics of right now. I don't want that to happen in this course. Now, why does that happen? I don't know. But back in the 60s, an ancient Chinese proverb was revitalized. And I would like to quote that for you because that's going to motivate the logistics, the mechanics of this course. The saying said, I hear and I forget. I see and I remember. I do and I understand. Well, the hearing and reading, I guess, go together. And that, I guess, would be the textbook. Seeing would be the videotapes. And doing would be the problems. In other words, a book by itself doesn't do much for you, especially the way most books are written. Seeing is great. You remember certain things, but you don't become proficient unless you truly do the problems, because that's when you understand. So to help gear myself to these three ingredients, I have made three components to this course. And by the way, I have to take the blame or the credit, whichever way you feel about it. Everything in this course was developed by myself. The content of the videotapes is mine. The content of the textbook and the study guide is mine. And in fact, if you have a first edition, the typing is even mine. Okay? And that's not meant to boast. I'm just saying I've put my heart and soul into this for you because it's a commitment as to how I believe people can learn. So the textbook, the videotapes, and the study guide are three layers that give a multi-dimensional approach to this course. In my own opinion, each of these three ingredients separately can teach you a lot about the course. But woven together, I think we have a foolproof way to help you learn. Let's just talk about the textbook first. If people can read, more words are better than less words. When was the last time you had trouble doing a do-it-yourself thing because the directions were too explicit? When was the last time you said, my God, I couldn't do this because they gave me too much information? Usually, there isn't enough information, right? See, the problem is sometimes people can't read. Now, if a person can't read, okay, more words is bad, but less words is no better. If you can't read, you can't read. And I'm even addressing that in part of this package. I am hoping for those of you who are leisurely learners, lazy readers, people who can read but don't like to, I'm hoping that I will rekindle in you a spirit of reading, because there is still much information that can only be acquired by reading. You know, if you rely on television to get the news, what are you really getting? You're allowing yourself 30 minutes, including sports, weather, and headlines, to learn all that happened that day. Somehow or other, there's nothing wrong with that, but if that's solely what you're going by, there's lots of stuff you're missing out on. So reading is important, and this textbook is designed for people who are willing to read. And if you're willing to read, what you'll find is that it's folksy, it's informal, and it's highly readable. And you'll also discover that I'm the one who's saying that. But actually, students have told me, who have taken my course, that when they read my book, they say to me, when we read out loud, it sounds like you're in the room with us. So be careful where you read the book, okay? But basically, the book will be readable. Secondly, most people have trouble reading long expositions. So rather than have long explanations, I have the continual use of illustrative examples. What you will do is, as you look through the book, you will find that after every few sentences, there is an illustrative example. The answer to the example is given in the margin, okay? Then you go on reading, and the solution is given, the comments are given, and in effect, I use illustrative examples the way newspapers use subheadings when they have long articles. Somehow or other, if a whole page of newspaper print is separated by bold-faced subheadings, it makes the article easier to read, and that's what I've tried to do over here. Thirdly, nothing is left for you to get anxious about. Every problem that's mentioned in the textbook is solved in the textbook. They're all illustrative examples, okay? And fourthly, there are margin notes to provide enrichment, answers, and other general comments. In other words, a lot of times a teacher wants to explain something to a student, something enriching, something anecdotal. Well, you can do that in a class. But when a person is reading a book and you start to inject these things, it gets very, very difficult to separate the enrichment from the hardcore computational techniques. So to help avoid that, there's almost like a second textbook. In other words, if you look through the margins of the book, you will notice little notes where I'm talking to you. And what you can do is you can ignore the margin notes altogether, or you can read them separately from the rest of the text. If you find them distracting, just ignore them, pretend they're not there. Cover them up with a sheet of paper. On the other hand, if you find them enlightening, read more slowly. There's no law that says you have to just rush through the book that rapidly. Okay? That's so much for the textbook. Now what about the videotapes? The videotapes, you're getting an idea of what they're going to be like right now, because this is one of them. And what the videotapes are going to consist of is I have divided the course into 12 modules. A module is a unit of study. I don't like to say anything more than that. Sometimes a unit might take you one sitting. Other times a unit might take you 2 weeks. We all learn at different rates. Some of us like some topics better than others. Basically, what we have here are 12 units that I want you to get through to finish this course. And in most cases, you'll be able to do this at your own pace. You'll have a video cassette recorder where you can put the tape in and watch it. And basically the idea goes like this. For each of the modules, there will be 2 tapes. One will be an enrichment tape. It will essentially go through the textbook with you, okay? So that is meant for 2 things. For the person who can read, sometimes by watching the tape first, it motivates the reading. For the person who doesn't like to read, watching the material can do 2 things. It can be an almost complete replacement for the text, or, like in many cases, a person doesn't like to read a novel, sees a movie that's based on the novel, likes the movie, and the movie motivates the person to read the novel. That's basically what can happen over here. In other words, I'm hoping that the enrichment tape will complement what you could have read in the book, and in some cases maybe almost replace it. The second tape will come at the very end of the module, where I will do a series of homework problems that have been assigned to you. I will do every one of those homework problems on videotape for you, and in great detail. Okay? So that's the 2 tapes per module. In addition to that, there are 4 special topics. There's a preface, that's the one we're doing right now. There's one on calculators, because that's an up-and-coming thing in the world of high tech. I'm going to tell you the good and the bad about calculators. Computing areas and volumes and some slight geometric concepts. People are afraid of those sometimes, so I have a special topic on that. And then when we end this course, our 12th module is an introduction to algebra. Algebra has a heavy emphasis on formulas, and so the 4th special topic is formulas. And basically, the only constraint I have in the studio is that a tape cassette runs 60 minutes. So basically, every lecture that you watch will run somewheres between 40 and 55 minutes. And I want to explain something else about that. There's no reason, as I see it, why you have to watch a lecture in one sitting. One of the greatnesses about a videotape machine is that you can do with it what you can't do in a class with the instructor. You can make the instructor stop whenever you want. You press the pause button, I stop talking. You press the eject button, you never have to look at me again. But basically, there's nothing that prevents you from stopping the tape, starting it up again, coming back at short interval, in other words, at frequent intervals to learn short amount of materials at a time. If the material is easy for you, you can go through the whole thing at once. You can come back to watch a tape after you've read a chapter. You can read the chapter, watch a tape, read the chapter again. I don't want to dictate to you how you're supposed to learn. I have tried to put together all of the ingredients that will allow each of you, in your own way and in your own time, to get through the course. You know, you don't do anybody a favor by rushing sometimes. If you can't sing better than Marian Anderson, it's no great deal to be able to sing faster. Take your time and learn well. And that's, okay? And also, these tapes are meant to be a superior talking textbook. I have tried to put these tapes together as if I was dictating a textbook out loud, except that I tried to project my own personality into it. I want you, as you're watching these tapes, to feel that we're an extended family. You're here to learn, I'm here to teach you, and together we're going to broaden horizons for both of us. That's how I want those tapes to come across. And to the best of my ability, that's what I'm going to do. But I can't be any better than how you receive them. And I deliberately didn't give you an address to write to me at because I don't know what that address will be from time to time, but it will always be made available to you together with a phone number so that you can stay in touch with me if there are things you want to talk about. At any rate, that takes care of the textbook and the videotapes. Now we come to the study guide. That's the third component of this book. And the study guide, along with me, is your tour guide. That study guide is going to tell you exactly what to do. It walks you through the course. You begin this course by reading the study guide. The study guide, and by the way, the study guide has as a preface all the things I'm telling you right now. In fact, it might be interesting for you to read the preface now that after you've watched this lecture, to see if the videotapes and the written material don't really coalesce into one nice unit. But basically what's going to happen with the study guide is it will walk you through the course. It will begin with an overview of each module. It will tell you exactly what to do and when to do it. It will tell you when to watch a tape, when to read, and also after you've read and watched the module, there will be 3 things in each module of the study guide that stays the same. There will always be something called check the main ideas. Check the main ideas is what I call an audience participation review of the module. What I do is I write an extensive summary of that whole module. And after I've written it, I erase certain key words and I replace them by blanks. So it becomes a fill-in-the-blank type of thing. And in order not to make you panic, all of the answers to the blanks are in the margin. So if you wanted to cheat, you could actually copy the words right into the margin. But either way, you're participating with me. And all I ask of you is, whether you do it legitimately or whether you copy the words from the margin into the blanks, that you read out loud what you get. Because when you read that, that's going to be a qualitative review of that particular module. And following that, there's going to be something called a mastery review. That's a unique self-prescriptive review coordinated with the illustrative examples in the textbook. I just wrote that down to give me something to say. But basically what that means is this. Remember I told you that the textbook had lots and lots of illustrative examples? Well, they're numbered. Now in the mastery review, there's a series of numbered problems that are word for word the same as the ones that are in the textbook. For example, in the mastery review, problem number 7 in the mastery review is exactly the same as illustrative example 7 in the textbook. So the idea is this. You go through the mastery review. Every time you get a right answer, that's fine. When you get a wrong answer and you don't see what's wrong, just go back to the correspondingly numbered problem in the textbook in the illustrative exercises, illustrative examples, and that will show you how to do that particular problem. And since the problem in the mastery review is the same problem only with different numbers, you see you're getting a self-prescriptive formula. You're being told exactly what you're doing wrong and how to correct it. Now, up until that point, everything we're doing is simply reinforcement of what's in the module. I want to give you a chance to see if you can go one step beyond. So at the end of each module in the study guide, we have a series of self-tests. Each self-test has 10 problems. And there are 3 forms of each self-test per module. And these self-test forms are numbered very innovatively, Form A, Form B, and Form C. By the way, in this whole program, whether it's the textbook or the study guide, there is never an unanswered problem. Because I want you to learn in a self-contained way, I don't hide any answers from you. By the same token, I don't want you doing more work than what you have to do. The philosophy is something like this. After you finish the module, you do self-test Form A. Every problem in Form A is worked out completely in the study guide. That's not the point. The point is all the answers to Form A are given. If you check the answers and you have everything right, that means you're eligible to go on to the next module. It means that you've gotten enough out of this module so that I'm satisfied with how much you know. But if you get any problem wrong, the problem is worked out completely for you in the study guide. So for example, if you get problem number 1 right, the heck with it. You go right on to problem number 2. You get 2 right, fine. You get 3 right, fine. Now you get 4 wrong, and you can't find out what you did wrong in number 4. All I'm saying is that right in the study guide, Problem number 4 will be worked out in great detail for you. Now, if we're lucky, the situation is you say, hey, now that I watched him do problem number 4 for me, I feel comfortable, but how do I know I could do a similar problem? That's where Form B comes in. The only time you have to do Form B is when you've gotten a problem in Form A wrong. If you did problem number 4 in Form A incorrectly, problem 4 in Form B is exactly the same problem with different numbers. It gives you a chance to redeem yourself. But this time, if you get it wrong, this is where that second videotape comes from in each module. Every single problem in Form B, in the self-test, in every module, will be worked out in detail in the study guide, on the videotape for you. And if you still need another shot at it, Form C is given, and that has only the answers. See, all of the forms have the answers, but Form C has only the answer. Form C is where I surrender. What I'm basically saying is, I've given you my best shot. If you're still having trouble, there may be a mental block, there may be an anxiety, there may be something I'm failing to communicate with. So I say to you, go see a friend, a tutor, a teacher, someone who can help you and get more help. See, sooner or later, there comes a time when you have to look for a new remedy. And I'm hoping nobody in this course falls into that situation, but it could happen, okay? So basically, this is the system, and I call this the delivery system. In other words, between the videotapes, the study guide, and the textbook, I am going to show you that content and human values can be taught side by side in such a way that each one emerges much more powerfully than it would have had it been taught to the exclusion of the other. And the key is going to be plenty of practice. I am going to try to make the lectures very interesting. I've tried to make the study guide interesting. I've tried to make the textbook interesting. And the reason for that is I want the course to be interesting for you so that you will be willing to put in the practice time that's necessary. On the average, you should expect about 2 hours of homework for each hour lecture. That's in a classroom situation. Maybe here, because I can cram in more information in a videotape lecture, because you see nobody's stopping me to ask questions, it's conceivable that you might require on the average of 3 to 4 hours to learn each module. Some will require less, some will require more. But don't measure by time. Measure by how you feel that you're growing, okay? In essence, my philosophy is this. If you say to me, teach me if you can, I love the challenge. I'm real good at it. If you say, teach me if you can, I think I have a 98% chance of success. But if you say, teach me if you dare, I quit. Because once you say, teach me if you dare, that becomes a self-fulfilling prophecy. It makes you almost proud to be able to say, see, I told you I couldn't learn. That was the inscription on the hypochondriac's tombstone. See, I told you I was really sick. No, I don't want you to be really sick. I want you to come in here with the attitude that even if you're having trouble, you are willing to learn. And if that happens, everything is going to be fine. And here's what you have to do. You're going to have to study hard. You can't just listen to me. In fact, I once had a student who was talking in class. This was during my early years of teaching when you weren't allowed to speak in class. I was a young instructor at MIT. I stopped my lecture. I looked at this young man. I said, Tom, what are you doing? And completely flustered, he gave me an answer 40 years ago that still has put me in my place today. He looked up at me very, very nervously. He says, I'm not doing anything, sir. I'm listening to you. And I suddenly realized you don't learn by listening. You learn by doing. Mathematics is not a spectator sport. You read mathematics with a pencil. And if you don't understand what's happening, you go back and do the problem over. If it's a videotape, you stop it and watch it again. See? Secondly, have fun. Don't confuse hard with not being able to have fun. The difference between work and play is not the difference between easy and hard. It's the level of enjoyment. My son hates to mow the lawn in August because it's too hot. But he's an excellent football player. And in August, they have double sessions, one in the morning and one in the afternoon. And he's never missed a double session. Why? Because even though it's harder playing football, he likes it. So don't confuse hard work with enjoyment. And thirdly, I have one that maybe you haven't heard before. I'm going to tell you to stay young. Now, some of you are already young and wish you could stay young. Some of you who are watching are beyond being young. and wish you could be young, I want to read you something from the Boston Globe newspaper. I don't usually read anything in class. This will probably be the last time I'll ruin a beautiful face by putting on glasses. But I have an editorial for you. Something kills that Kojak look right away. Let me just read this to you. And I just hope that you'll enjoy hearing it, because it sort of gives me tingles when I read it. The whole thing is kind of lengthy, but let me just go with it. It says, "The American obsession with youth results in billions of dollars being spent on elixirs, exercise classes, and other erotica. But the best remedy for staying young is state of mind, according to British-born anthropologist and prolific writer Ashley Montagu, who for years has taught at Princeton. At 78, Montagu knows firsthand about age. He writes of growing young, the dream of millions of Americans. Montagu finds that most adults aren't curious. They're not curious. They find little humor in anything. They have lost their open-mindedness and their willingness to experiment. Most have lost their eagerness to learn, halting their pursuit of knowledge or understanding when they stop their formal schooling. He calls this speedy reach for maturity, this stifling of spontaneity, he calls this psychosclerosis, or the hardening of the psyche. The cure he prescribes is relearning how to play, rekindling that natural curiosity, that recultivating the flexibility inherent in all children, recapturing that youthful zest for life. In other words, relearning how to act young. Retaining any semblance of youthfulness is difficult in a world dominated by pitfalls and pressures that force a person to grow up quickly and with little peace of mind. It is important to try to think young, as scientific and other achievements result in an increased life expectancy for Americans that hovers near 74. By cultivating the fountain of youth within, as prescribed by Montagu, perhaps many can avoid the common plague of growing old before their time. And with luck, may you achieve the result of his best possible advice, to die young, as late in life as possible. And that's going to be the philosophy of our course. I am going to do my best to make you want to learn, because when you learn, your mind is young, and when your mind is young, you're young. And that's going to be our motto throughout this course. We're going to have a standard beginning, so you'll know when the course is starting. There'll usually be an anecdote, not always very funny, but hopefully appropriate. And we're going to end every lecture with the little commands I've given you over here. To do what? Work hard, right? Have fun, stay young.